Kia ora everyone, lovely to be here. Christine, do you mind if I have that?
Yeah.
It is such a pleasure to be speaking to you all this morning at this incredible event, so huge thanks to Creative Mornings. And to be speaking to you about my book Ultrawild, which is here. This is my graphic novel-like book. It's science, it's not a novel, but it's a graphic novel type format. It's a book about ideas, big ideas to change our world rapidly, to address climate change and biodiversity crises. And what a place to be talking about this. Wellington. Hands up if you know that this city of ours, this beautiful city of ours, is the epicenter of urban rewilding in the entire world.
Yeah.
Yes! We are. And I'm going to show you a few bits on that through the presentation, but I'm so proud to be here and of the amazing things that we do in this city of ours and in this country of ours. So, there's me. I'm the narrator in Ultrawild. It is about transforming cities really fast. So how do we move from this to this? We currently design cities for one species, for humans. But I argue that we need to design cities for all species. This is what we have in the image here. This is an idea that the vast majority of people consider completely absurd. How on earth would you design cities for all species? But I argue that it's vastly more achievable and possible, and in fact we're already showing how it can happen right here in Wellington. It is also a book about having fun with ideas. It's a book about being as silly as possible. Partly because we're dealing with some really, really worrying and disturbing ideas and themes. We're all worn down by some of the things going on globally. And so it's incredible to have fun and to feel joy around design and art and creativity. But also because the latest science tells us that having fun with ideas helps us achieve creative breakthroughs. Ludicrous ideas are boot camp for brains. This is what I say in my book. And this is Dr. Shelley Carson. She's an academic at Harvard University, a psychologist. She has written a book on creative thinking, and she says, by forming mental images of highly unlikely scenarios, you're training your brain to think outside the proverbial box. The more you practice what-ifing, the more easily you will be able to visualize unusual scenarios, and the more likely you are to come up with ideas when you need to generate a novel solution to a problem. In essence, to get out of some of the very, very complex problems that we're in globally, we need to have fun with wild ideas. That is what science tells us. It's also a book about technology. Because technology is moving, as we all know, at such an incredible rate that I argue that some of the solutions to our problems may be much closer than we think. Take this, for example. This was the world's most powerful supercomputer in 2008. It's called the IBM Roadrunner. It was the first supercomputer to have a petaflop of power, right? I'm not going to get into what that means, partly because I can't really explain it, but basically it's a mega computer, right? This cost $145 million in today's money, okay? It took up the whole room, it used vast amounts of electricity. That was in 2008, 17 years ago. If there is a 17-year-old in this room, in their lifetime, we've gone from that to this. This is a new NVIDIA computer announced a couple of weeks ago. This is the first kind of desktop computer that has a petaflop of power. So we have gone from that to that in 17 years. It's quite incredible. And that is, of course, going to happen again and again and again. And it has huge implications on what we can do, on the data we can collect, on the ways in which we can think about the world, in the ways in which we can prototype solutions, map out ideas to change this crazy world of ours. This is an AI camera developed by Zip here in New Zealand. It is a device, an infrared camera is inside here. It films wildlife. It uses AI to work out, is this a bird, is this a cat, what type of bird, what age bird, and it's linked to multiple other cameras through the mountains, and it creates an incredibly sophisticated data set of what's going on in the bush. And that allows us to have targeted pest removal. So this is just one example. This is essentially got inside of a computer that only a decade earlier would have been a supercomputer. So this is an example of how technology, I think, can help us. And of course, technology also has a lot of problems as well. I mean, we all know about energy use from AI and all kinds of other problems. But I argue that we need to look at the positives that we can use technology for to help us with biodiversity. These are all innovations from this country, by the way. This is a trap which uses AI to determine whether something that crawls up here is a rat or is a bird, so can kill the animal depending on whether we want to kill it. This is a facial recognition system, also using AI. This can map the faces of individual reptiles, and it can actually build up essentially a family tree of what's around on the ground so that we know exactly who's going where and how populations are faring. So really incredible stuff is happening. This is a forest planting drone. This is, of course, our good-natured trap from this city here. These can be linked up across the hills and can all talk to each other and share data on what's happening. This is a hollow for an owl that has been 3D printed using a wood pulp. This is from Melbourne University. One of the projects in my book is a 3D printed bird, which prints habitats. And after the book came out, a professor from Melbourne University called me up and he said, "Hey, Steve, I love your book. I wanted to show you what we're developing. We're already doing these 3D printed habitats." So there's cool stuff happening in the world, which is as crazy sounding as the ideas in my book. On the other side of this is an opening. This is a 3D scan of a powerful owl hollow in a giant eucalypt tree in Melbourne. The reason you would want to 3D print a hollow is because in Melbourne they want to invite powerful owls back. These are great big owls about this big, but they require trees that are hundreds of years old in order to have hollows large enough to house the owl. We don't want to wait hundreds of years to bring those owls back, so we 3D print them, a hollow based upon their preferred habitat style, attach it to a much smaller eucalypt tree, the owls move in, hey, you start to build up a population. So this is the kind of example of things that are really exciting me. Well, and here, this is the same project team in Melbourne. They are using AI and a 3D model of Melbourne to work out where habitat could be added to the city. So each one of these coloured dots represents a different type of habitat, whether it be a habitat for birds or insects, plants, etc. So really, really cool stuff is happening in this world. Here's me, and here's how I start the book. This is me in a beautiful forest just outside of Melbourne called Toolangi State Park. Would you believe, you would probably believe, this forest was about to be logged to create photocopying paper until just 2 years ago. This is an 800-year-old tree with a footprint about the size of half of this room. Okay, that is still happening all around the world, as we know. The world's cities are expanding rapidly, gobbling wilderness and belching carbon dioxide at an ever-expanding rate. But transforming cities into multi-level carbon-sucking ecosystems isn't impossible. I started thinking about rewilding cities while walking in a cool temperate rainforest in southeastern Australia. Gazing up at 20-storey tall mountain ash trees, I began wondering what it would take to return such giants to cities. To live amongst them with millions of other species, a kind of extreme version of rewilding. I called it ultrawilding. And I decided to invent whatever it takes to make it happen. The more bonkers the ideas, the better, but the inventions had to be possible. That was 7 years ago. I've been thinking about it ever since. So the book took me about 7 years. It started off with the idea of transforming cities into ecosystems, and gradually I realized that actually what we wanted to do was to rewild cities, not just kind of add rooftop farms and bits of greenery on buildings, but actually completely rewild cities. To make cities places for all species, not kind of greener places just for humans. And I had to invent this word, ultrawilding, because rewilding, one of the things about rewilding is it's about humans doing what is needed to allow other species to thrive and then stepping back. It's actually about us letting nature thrive on nature's terms, not intensively managing nature, which is what typical conservation is about. So rewilding can't really work in a city because cities are packed full of humans. And so I had to invent a new word, ultrawilding, which is rewilding, but allowing us to sort of fit in with it. So it's basically saying, how do we rewild cities to make them as good a places as possible for all species, including humans? And how lucky are we to live in this city of ours? Of course, we have all the hills that meant that it was difficult to build everywhere. And so we had lots of space for nature to cling on. We also had the town belt, which of course was initially planted with exotic trees for masts for boats. Of course, you no longer needed masts, so the trees were left where they were, and now those are being replaced gradually by native bush. Really incredible situation. You know, as a kid, I always thought Wellington was good in spite of the hills and the wind, and now I think it's good because of the hills and the wind, because the hills mean we haven't built houses everywhere. If it was a flat city, there would be no bush here. And the wind, well, that just makes us a bit more hardcore, doesn't it? So, I think we are leading the world in ultra-wilding. Zealandia, we've got some representatives from Zealandia here. What an amazing demonstration of urban rewilding. And all of this is packed full of research. People are performing research all throughout the hills here on how we can bring species back. And look at this. This is a bit cool. This is Treepedia, apparently the authority on what cities have how many trees, right? And here are the 3 most tree-covered cities in the world, okay? Singapore, 29.3% of tree cover. Sydney, 25.9%. Tampa in Florida, 36.1%, right? Sounds pretty impressive. But wait, I forgot about Wellington. Here is a study from Canterbury University that shows that in Wellington we have 30.6%. Okay, so we're currently at number 2 after Tampa and Florida. And this is all the new rewilding that is going on in green. These are the current projects. These are projects that have recently been planted up. This adds a massive amount to this figure here. I argue that probably these guys need to add us in at number 1. And here we go, one of the coolest projects, I think, one of the most inspiring projects to me, Capital Kiwi. These little dots here represent traps and other monitoring equipment. This is, of course, where all of our beautiful kiwi are returning. What an amazing project. It was the front page news on the New York Times, and I think about page 4 here in Wellington. I don't think we have any idea what we have in this city. We are doing some incredible stuff. And rewilding is an incredibly powerful tool for reversing climate change. Ultimately, my book is about climate change. This is a quote from a recent paper published in Nature. Restoring 15% of converted lands in priority areas could avoid 60% of expected extinctions, while sequestering 299 gigatons of CO2. 30% of the total CO increase in the atmosphere, or 14% of total emissions. Pretty amazing. 15% of priority areas. That sounds pretty doable, right? But hang on a sec. What exactly is a gigaton? We're going to get to that in just a moment. This is what I based my book on. This is from an IPCC report. Basically, the IPCC has mapped out various pathways forwards for keeping global heating to below 1.5 degrees, which is what we want to do if we want to avoid all the terrible dystopian futures that we read about. Okay? If we look at this chart here, this is carbon emissions today, and we need to bring them right down. Okay? If we stay in the blue, we stay under 1.5 degrees. These are much more serious and nightmarish scenarios. And what this basically says is, in order to keep global temperatures at under 1.5 degrees, we need to not only stop emitting, but we need to pull carbon dioxide out of the atmosphere. So it's not just, so we can't just, if we all move to electric cars and if we all move to solar and all move to wind as fast as possible, we're still going to have to draw down that excess carbon dioxide that we've already emitted that is in the atmosphere and in the oceans. And so this here, 100 to 1,000 gigatons of CO2 is what my book looks at. Could we rewild enough of the world to achieve that? Because people aren't really talking about rewilding to do this, or at least some people are, but a lot of people are focusing on technology, great big machines that suck carbon dioxide out of the air. I think we can do it with vegetation. I think we can do it by giving biodiversity an enormous boost. And so that's at the crux of Ultrawild. And so I'm going to read you this little bit here from the book. I say, okay, but could rewilding actually crush climate change? Rewilding is a stupendously powerful tool for solving the trickiest part of climate change. The bit no one has figured out yet. The bit most people don't know about. The bit you need to help solve. The bit with a $100 million reward. We all know that burning fossil fuels produces carbon dioxide, a greenhouse gas that's trapping heat, warming the planet, and driving millions of species to extinction. And we all know that the only way to stop climate change is to quit fossil fuels, a challenge so huge it will require every creative mind on Earth. But what most people don't realize is that once we stop burning fossil fuels, there will already be too much greenhouse gas in the atmosphere. If we do nothing, this gas will keep the planet too warm, melting ice sheets, rising sea levels, and driving species to extinction. Which is worrying, because last time the atmosphere had the carbon dioxide concentration we have now was around 3 million years ago. Back then, the extra heat meant there were forests in Antarctica, and the sea was up to 25 meters higher than today. In other words, we'd be underwater. So, to stop the ice continuing to melt, rising sea levels and flooding cities, we also need to suck carbon dioxide back out of the atmosphere and store it, a process known as carbon sequestration. And that's where rewilding comes in. So, how much do we suck? Since the Industrial Revolution, we've produced roughly 2,500 gigatons of carbon dioxide, a ludicrously large amount that's difficult to imagine, partially because it's tricky imagining gases having any weight at all. So, giga means a billion. So 1 gigaton is 1 billion tons. You can think of a small car weighing about a ton, and 1 ton of carbon dioxide takes up about the volume of a house. So imagine the volume of this beautiful space we're in today, the whole space. 1 billion tons of carbon dioxide is roughly the volume of Mount Everest. So I was looking for a way to describe what a gigaton is. I was looking for objects that were large enough, and I eventually came to Mount Everest. And it turns out that if you sort of model Mount Everest as a perfect cone, it is basically the same volume that a gigaton of carbon dioxide would occupy. So you imagine 2,500 Mount Everests. Really hard to imagine, right? But just imagine it. That is the amount of carbon dioxide that we have released into the atmosphere. And that is roughly the amount that we need to draw back down if we want to completely reverse climate change. It is only the greatest, the most stupendous, the most incredible challenge we have ever faced as humans. Which is kind of cool. I mean, terrifying, but hey, it's good to have a challenge. There is no safe amount of carbon dioxide pollution or global warming. Already thousands of species are at risk. Ideally, we'd suck back all 2,500 Mount Everests of carbon dioxide, reverse the world's temperature right back to what it was, and save every single species. But very few people think that's possible. And so world leaders are aiming for no more than 1.5 degrees of global warming. This will give us a good chance of avoiding catastrophic climate meltdown, and so hopefully saving most species. And what I go on to say is that, in essence, we need to aim to suck roughly 100 Mount Everests, 100 gigatons of carbon dioxide back into our biosphere in our lifetime. And that is an amazing technological challenge that no one really knows how to achieve yet. People are inventing all kinds of contraptions that suck this stuff up. But the best way to do it is with nature. We all know that trees absorb carbon dioxide and make wood, but rewilding takes natural carbon sequestration to the next level, because ecosystems of thousands of different species of plants, insects, birds, amphibians, fish, reptiles, mammals, fungi, microbe, epiphytes, and others, all working together, store massively more carbon than forests and trees alone. And it's a lot more fun too. So I wanted to start off with that because I've actually, I've never explained in a talk the background to the book in this way. And a few people have asked me recently to kind of talk them through this whole Mount Everest thing. So from here, I'm going to tell you about a couple of the thought experiments in the book, because I know we haven't got a lot of time today. So I'm just going to jump into 2 of them. Am I good for time, Christine? Cool. Here is an image of London, a rewilded, an ultra-wilded London. You can see Big Ben in the background. You can see that the ground level has been completely given back to nature. This is my vision for every city in the world, that nature reclaims the ground, that us humans, we move up. We've got a 3D printed bird here. And then we've got some other really interesting... Oh, we've got bicycle paths and paths for autonomous vehicles. Then we've got some other interesting creatures. We've got real lions. We've got hippos. We've got elephants. But that's weird, isn't it? Because those animals are from Africa, right? But no. 10,000 years ago, where London is built, there were elephants, lions, and hippopotamus. All of those animals roamed Europe. And the fact is, 99.99999% of people, even living in London today, have no idea about that. Because we have lost the memory of the animals which lived where we live. Some of these animals, I think it was I can't remember whether it was the elephants or the lions, were in the UK until just 5,000 years ago. Quite recent, very recent on a geological timescale. And what I'm going to do is, with each of these two projects, I'm going to show you a couple of things that have inspired me, because this series is about journeys. And I want to tell you a little bit about what's behind Ultrawild, because books like this don't just spring out. They just bubble away in your minds over years, over an entire lifetime. So, would you mind hitting... Are you ready, people? Press play, the little button up the top, down the bottom. Dude. When I was 5 years old... When I was 5 years old, my mum took me to Return of the Jedi, and I was blown away by the Ewok village, right? And of course, everyone was on the side of the Ewoks, right? How cute were these little guys? They were fighting back against the Empire. The Empire had the Scout Walkers, and they were like dropping logs on them. Really, really influenced me. And I think that was one of the first times I can remember thinking about wanting to live in cities that were like jungles. When I was 8 years old at Makara Primary School, I discovered this book, Design for the Real World. An amazing, amazing book about from the late 70s about eco-design and about how we can use design to change the world. This had an enormously profound effect on me. This here stuck in my mind. This was this is made of paper. They're about this big, filled with seeds. The paper is impregnated with seeds. They're designed to be dropped out of aeroplanes by the million, and to basically roll along in the desert and to help rewild the desert. And this stuck in my mind as an 8 or 10-year-old. This book here I read at university, The One Straw Revolution, Masarunobu Fukuoka. Absolutely wonderful book. And in it, he basically transforms a farm in Japan into a much more sustainable environment. And he talks about, have I got a picture here? No. He talks about seed bombs. Ningo Dango, which are tiny little, basically seeds, clay, fertilizer, roll it into a ball and throw them and help rewild landscapes. So these are things that have inspired me over the years and which sit behind Ultrawild, because this is the journey of Ultrawild. It didn't just begin when I started writing the book. It really began with all the different things that have inspired me over the years. For many years I worked at Ceres Environment Park in Brunswick in Australia, in Melbourne, Australia. And while I was there, I was involved with all kinds of research projects looking at interesting technologies like composting loos. How do we take human waste and turn it into nutrients for ecosystems? How do we build reed beds which filter our wastewater and allow us to put our wastewater back into our ecosystem rather than having to pump it far, far away? There is so much to be learned from this type of research. I mean, think of what's going on with our pipes and our problems here in this city. I'd argue that we could be learning a lot from this, and we could probably find much, much better ways to solve some of Wellington's water woes. And books are also full of collaborations. So Ultrawild isn't just the result of me thinking and me drawing. It's the result of me jamming ideas with a lot of people. So this is my mate Neil. Neil is a mechanical engineer. That's Neil and I in our apartment in Melbourne, just as we've cracked an idea. This is Michael Santon. He's a race car engineer, also a mechanical engineer. And there's Neil working on one of the solar dishes, which was also one of our projects when I worked at Ceres. So Ultrawild is about bringing everyone in, and that's a really important part of the journey. This is Dr. Wilson Leonard, and Wilson and I developed this greenhouse here. This was an intensive aquaponics system designed to showcase how we could grow food really efficiently in cities. It's aquaponics, which means you collect fish waste. You've got fish in a great big pond. The fish waste is channeled through, and you use it to supercharge veggie growth. And this is one of our projects at series. So just to go back a sec, this beautiful little eco park, we had about $1 million of funding to develop technology projects back in about 2010. And we developed a whole lot of things, including working on a biogas digester. That is a machine which takes waste and produces gas to produce energy from, and also produces a kind of a nutrient-rich fertilizer. This kind of never went ahead. It never got beyond a concept study. But all of these projects feed into this project I'm about to talk to you about. So, in the book, there's a chapter called the Mechanical Megafauna Project. And the question is, the thought experiment, because you've got to start with a crazy idea. Could we replicate the soil-creating work of large animals with compost-firing cannons? Because in cities, we no longer have lions or elephants. We no longer have moa roaming the ground right where we are sitting now. 9 species of moa roaming across this country. Those animals are gone, and so is their manure, so is their waste. How does that change an ecosystem? It changes it dramatically. And so, in the back of my mind, when I started this book, I had all of that work, working on compost loos, reed beds, aquaponics, and I started to think about, how could we supercharge ecosystems in cities? I'll just read this bit here. It's difficult to imagine hippopotamus-sized wombats blasting footballs of dung right here where I'm sitting at my desk. But once upon a time, massive megafauna-spreading mammals known as megafauna massive manure-spreading mammals known as megafauna roamed the land that almost every city is built upon. Along with smaller animals, they launched an unbelievable amount of manure. To find out just how much, so that we could replicate this extreme dung spreading with cannons, I looked at scientists' best estimates of how many more wild animals there once were. Turns out that the land that Melbourne is built upon could have been home to over 30 million wombats, kangaroos, wallabies, and other mammals. But once, there could have been over 200 million mammals in the same space. 7 times as many, including supersized megafauna wombats, marsupial lions, tapirs, demon ducks of doom, and many more. So isn't this amazing? You know, we know that, we kind of know that big cities used to have wildlife where the buildings were, but do we think about the megafauna? Very few people are sitting in Melbourne, or walking around or sitting in Melbourne today thinking about these beautiful creatures which lived 30 to 60,000 years ago. And these are some of the other animals that roamed around the world. This one in particular I love, okay? This is a rhino with a 2-meter long horn that lived in Eastern Europe, okay? This is apparently the part of the basis of the unicorn myth. And here is a model of this creature. A 2-meter long horn. Has anyone in this room ever heard of this animal before? No. But they existed just before humans started roaming around Eastern Europe. And they existed for long enough for us to write stories about them, which became the unicorn myth. Apparently some of these horns were 1 meter wide at the base. Can you imagine a horn that's that wide and that tall? I mean, imagine facing off against this animal. I want to bring them back. Don't you? Don't you? Some of the science that influenced this project, the Compost Cannon Project, is really quite disturbing. This is an amazing paper, the biomass distribution on Earth. In it, the scientists set out to map out just how many mammals are there on Earth. And what type of mammals do we have? If we look at all of the animals on Earth, what categories do they fit into? And this is what they found. This is part of what they found. Of all the animals on Earth, 96% are livestock and humans. 96%. Only 4% are wild animals. It's unbelievable, isn't it? I mean, we have displaced the vast majority of wildlife. And so this project is about how do we bring them back. And of course the way to do that is to start off by supercharging the ecosystem into tremendous habitats so these animals can come back. This is a megafauna emulator, as you can all see. The basic plan is pretty simple. You blow up every toilet in the world. You 3D print a megafauna emulator. Okay, it's a moss toilet seat, as you can all imagine, way more comfy to sit on a moss toilet seat and never need to clean it. You use virtual reality while you're on the loo. It's pretty boring being on the loo. So you use virtual reality to gamify your experience and also to allow you to collect points. And when you add the compost can, and I should say that this book is all about design iterations. So this was the first idea. I wanted to have a wheelbarrow. You'd basically produce your waste. It would be broken down by insects. There it would go, put into the wheelbarrow, and then you take the wheelbarrow out to the garden. Of course, we're pretty lazy as a species, so no one's going to do it. I mean, we never empty our compost bin in the kitchen and start smelling. You can see the problem. So we needed to move on to something else. This is a compost cannon system, okay? It's the same megafauna emulator. You add a biogas digester, okay? Remember I did that study on the biogas system in the eco park? You add a mini one of them, you collect gas, you use that methane gas to blast the compost cannonballs. By the way, this is compost coming up this pipe, dropping onto this conveyor belt, being packed into balls, into seed bombs, covered in toffee. Hands up who can tell me why you always must cover compost cannonballs with toffee. You must. Anyone? AJ. Compost cannonballs must always be covered with toffee. Why?
Why wouldn't you, Steve?
Yeah, why wouldn't you? That's right. Everything should be covered with toffee, right? The reason is simple, aerodynamics and holding the thing together. You don't want to start a compost cannonball with your neighbours, right? You want to launch a compost cannonball far away onto motorways and other places that we want to rewild. Okay, so in my book, I do all the maths with the help of some buddies. Here's my house in Brunswick. Here's me blasting a compost cannonball onto the road. And what we worked out is that each one of us, megafauna, and yes, we are megafauna, technically, each of us blasts enough nutrients in our waste to rewild roughly 1 tennis court of forest each year. Okay? There are 40 of us in the room. We could rewild 40 tennis courts this year. This is the Star Wars inspired megafauna emulator loo that I always wanted to design ever since I was 5 years old and I went to Return of the Jedi. Do I have time to tell you about one more? Should we leave it there, Christine? One more? Do we have time for one more? Yes. All right. So we need chickens on rooftops and we need chicken castles, and chicken castles must be armed with lasers. Do you want to know why? Yes. Great. This is Tokyo, by the way. This is a chicken castle, which is basically a defense system for chickens. There are 33 billion chickens in the world. It's a lot. I argue we should liberate them from their cages and we should collaborate with them because they are the most amazing ecological engineers. Who here has kept chickens? You have? Great. So I want to talk to you about some of the influences. This is Bill. I lived with Bill in a flat. We had chickens. Bill built bicycles. How cool is that? We had chickens, and what we found is that chickens transformed our garden really, really quickly. The digging, all of the manure, they turn your veggie scraps into wonderful soil. So we have 33 billion of these friends. I argue that we want to put them on roofs. Part of the idea in this book is that we give every rooftop in the world to chickens. So we do an interspecies collaboration. A couple of other influences. This is a dish that we developed at that same eco park. This is called a Scheffler dish. It's a concentrated solar dish. It concentrates sunlight. I'll talk about that in a sec. This is my dear friend Frankie, who works at NIWA. Frankie is a marine scientist, marine biologist. He's just finished his PhD, and that's him and I calculating all of the bits and bobs to work out how we could do this Chicken Castles project. So each of the projects is a collaboration with scientists. And how cool is this office? Doesn't this make you all want to be a scientist? You know, you've got like whale posters and, you know, maps of ocean currents, plates with toast crumbs, cups of coffee, peanut butter. Chickens are shrunken megafauna. Could they help us create gardens that are safe from savage animals? So we want to bring back animals, like the ones with the enormous 2-meter horns. We want to bring back lions. We want to bring back elephants and bears and all the rest, moa. But of course, we also don't really want to be torn apart. I don't know about you guys, but I mean, it would make life more adventuresome. I initially began thinking about chickens because chickens wouldn't live very long with wolves denning in your garden. And with lions, they'd be instantly torn to shreds, probably along with a few of us too. But it was while thinking about how humans and chickens have lived together for thousands of years and how chickens perch in trees to stay safe that I had a few ideas. To stay alive, we need to garden upwards. We need to build civilized gardens on every roof in the world, and we need to accept total carnage on the ground. And to do this well, we need chickens on our side. The basic idea is we want to give the ground back to nature to be wild. We want to move human food production upwards, and chickens are our best ally. Over 100 million years ago, T-Rexes evolved to be smaller and smaller to survive on less and less food. This helped them avoid extinction with the rest of the dinosaurs, and today we have the humble chicken. But chickens kept their ancestors' laser vision. They see using ultraviolet light and perceive far more detail than we can. This allows them to be ultra-violent in a very helpful way. They pulverize vast amounts of microscopic soil grubs into manure. Then there's their legs. Just like the T-Rex, chickens have mighty stompers, making them super powerful diggers and stunning soil engineers. But less well known is this. Paleontologists believe T-Rexes were as intelligent as chimps. And their miniature descendant, the chicken, which most people tend to think is utterly brainless, experiences complex emotions, has dreams at night, can do basic maths, and can solve simple problems by anticipating future events. Chickens are ultra incredible. We have to collaborate. I'm going to leave it there.
Yeah,
because you've got to read the book to find out how we need to collaborate with chickens. I'm sorry that's been a bit longer than normal, but hey, had a little bit to cover. Do we have any questions? Come on, criticize me, take this apart. AJ, yes, I knew you'd have a question.
This is a 7-year-long project?
This book took about, it actually took 8 years, but that just sounds embarrassing, so I say 7. Yeah.
Good odd number. What would you do differently, or what was the biggest thing that you learned doing such a protracted project?
Yeah, it's such a great question. I was so ashamed for so many years about how long it took to create this book. But the more I got into it, the more I realized that books take time. And it's not, if I was just to write that and draw it out from scratch today, it clearly wouldn't take 7 years. But ideas just take time to gestate in your mind. Books require chance meetings with people who inspire you. Listening to a podcast, running to your notebook and, oh my God, that's the way I'm going to solve this problem. Good design, good creativity just takes time. And so, in actual fact, sure, I would love for this book not to have bankrupted me. And sure, I would have loved to have got it out of my life after a year, but I actually think that 7 years was necessary. I reached out to a lot of people with this book. There are a lot of scientists involved, a lot of engineers, a lot of people were very generous. I probably would have reached out to more people. I probably would have reached out to more communities of writers and illustrators, but I felt ashamed about it for the longest time, and I kind of just did it by myself in my cave. Yeah, so I think always it's got to be more people connections. That's got to be the solution. Yeah. Yes.
I'm fascinated by all the illustrations, and there are so many on every page, and they're all really cool pictures. And I just wonder are you quick at drawing, or?
No. Look, not many people are. Drawing takes time. I can do a quick sketch, but to lay out a book, I'm going to flick to a page here. This is a spread from the book. When you produce a spread, each picture is a little world. Here I had a little gag about this. Earlier in the book, you learned that we all need to have armoured umbrellas to protect us from incoming compost bombs. And so in this book, I eventually give chickens little mini armoured umbrellas. But then, of course, we get to this bit, and it says here, at least that's what I thought. But here's the thing. Once I had built a handheld methane cannon, I came to a surprising conclusion. Cannons are not ideal for feeding chickens. And then it says here, chickens don't know how to defend themselves with armoured umbrellas. So right there, you've got a little joke, you've got a little picture. I mean, I could, if you told me that, I could draw that in a minute or so. But to think up the joke, to lay it out on the page, to draw the final thing, hours. Bizarre. I mean, it's hard to fathom how long it takes to work on a book, but the ideas just very, very slowly take place. There are some sketches that came to me really, really quickly, but overall, I would say a spread like this, I would be working on for weeks. Yeah. So it's a very slow process, and a little bit like the answer to AJ's question, I would say that slowness is actually necessary and beautiful, and as frustrating as it is at the time, it's just what you need to do. Yeah. Yes?
Hey, I do want to share a little anecdote in the book, How Big Things Get Done. The author shares that even Daniel Kahneman himself fell victim to a bias where he thought his project was going to take a year and wrote a book and it took 7, so Daniel Kahneman, it's okay.
Thank you. Oh, look, okay, so this is how it works, right? And has anyone here published a book or been on a similar sort of journey? Yeah. So you say to your publisher, yeah, here's this concept. And they're like, yeah, we love it, Steve. Can you have it done by February next year? And you're like, of course, of course. You know, I have the most beautiful, wonderful publishers in the world, right? Okay. So here they give me this 1-year goal. And then, you know, I get to a few months before the goal and I have to go cap in hand. I'm like, I'm really sorry. Can I have just a couple more months? And they say, look, Steve, we can see that this is an ambitious project. Unfortunately, we can only give you another year. And I say, no, I can't, not another year. I need to go and earn money, you know. A year is too long, just give me a couple of months. No, Steve, it's a year. We'll see you in a year. And I think, oh, well, at least I'm going to be able to do a great job of it, right? A year, whew, it's going to be great. Fast forward another year, and I'm back to them. Yeah, look, I mean, this has been pretty full on. It's taken a wee while. Do you mind if I had just 6 months? 6 more months. No, Steve, another year. Can you imagine I was in that situation year after year after year? I couldn't go to parties anymore because people were saying, because I'd say to people, yeah, I've got this book deal, it's going to be ready in a year, and I'd go to a party and be like, hey, where's the book? Like, oh, yeah, in about 6 months. And then I'd go to the party the next year, and oh, the book must be finished. Oh, no, it's not finished. It was so deeply shameful. I mean, I'm making light of it now, but these things just wear you down. By the time I finished this book, I was on my knees. And that's just what it is. Yeah.
Yeah, I was going to ask, I also think you must have had quite a few moments. I mean, the idea of giving up, clearly, I don't know how it featured, but maybe don't go into that.
Oh, no, I was never going to give up.
Oh, that's amazing.
No. I mean, all my friends were emailing me solid council jobs. Hey, Steve, you should get this job. It's great money. And I'm like, what? Don't send me your council jobs. Yeah, I don't know how or why, but I just knew I had to finish this project. Yes?
Congratulations.
Thank you.
So in that journey and in those deaths there, were you keeping an audience in mind? And like, my daughter loves it, I love it, so I think it's got a broad audience. But is that...
The book is for me as a 10-year-old. That's the audience. I mean, I think I didn't ever think about that. You know, people kept saying to me, have you shown it to kids? I never showed it to anyone. I mean, apart from my collaborators, my little close friends, because it's just this thing that you do for yourself. And you just have to trust that if you want it, other people are going to want it as well. Yeah. The book has an innermost cave section. So originally, the book was going to be a whole bunch of discrete ideas, completely unconnected ideas. And actually, the book began with a project in Sydney. I'm pointing to Sophie here because Sophie was involved with that project. It started, when was that, 2011?
No, 8.
2008. It began with a whole bunch of projects that I presented with the Australian Centre for Design, and they toured around Australia. And I just thought basically I would turn those projects into a book. But what I didn't realise is that if you want to build an eco-city, it doesn't work to just have a few or a whole bunch of random projects that are disconnected. The whole city has to work together as an ecosystem. And this is my innermost cave page. So this is where I cut to black and white. Along the way, I realised I had to rewild every city on Earth. I had to provide a bit of a blueprint for that. And it was during the fires in Sydney. If we'll remember, we're going back to 2019. I remember riding my bike to a little pond area in the middle of Melbourne. The sky was darkened out by ash from the fires 1,000 kilometres away. And I just cried. You imagine spending 7 years working on a book about reversing climate change, and you expect it to not even be needed, because you expect that climate change will be solved. I mean, how many of us thought that we'd be right on top of this years ago, decades ago? And as I worked through the book, the problem got worse and worse and worse and worse and worse and worse and worse. And I got to a point where I didn't think that I could produce a design and science comedy about climate change, given the situation we're in, and which has only got vastly worse. And that is what this Innermost Cave is about. So I had a lot of doubt. I had a lot of doubt about the project, not about myself being able to finish it. I knew I had to finish it. But that Innermost Cave moment was pretty important, because, and you'll have to read the book to find out, but it did actually help me get through, and it actually allowed me to have a bunch of epiphanies, which gave me a lot of hope. Yeah. Should we finish it there?
Yeah, I think so. Well, big round of applause.
Thank you.
Where Steve has brought in a whole load of Ultrawild books for selling. If anyone would like to purchase a copy today, he might be persuaded to do a little doodle and sign the copies as well. So if you can hang around, or you have any other questions for Steve, you're going to hang around a little bit.
Yeah.
And obviously, if you need to head off to work, then I hope you have a wonderful Friday. And we'll see you in approximately 4 weeks' time.
Thanks so much for coming, everyone. Thanks for being late to work. You're awesome.